Okay. All right, so kind of the big important piece for number 4 here, starting with part A, and where it's asking us what is the absolute risk reduction in melanoma from regular tanning versus no regular tanning. And so we have that information already in problem 2. We just kind of have to bring it down and then find the absolute risk reduction. Right? So the absolute risk reduction would be the difference, right, between the two groups. So from number 2, we knew that regular tanning, or we could say the absolute risk of regular tanning is 0.35%, okay, versus the absolute risk of not regular tanning or no regular tanning was only 0.2%, right? So then to find the absolute risk reduction, we would just subtract these two, right? So we take 0.35 minus 0.2, and that should tell us what we're looking for, right? So the absolute risk reduction would just be 0.35 minus 0.20, and that's going to get us 0.15%. Okay, so there's an absolute risk reduction. There's a difference in percentage value of 0.15. Okay, and that's essentially all we need to find there. Okay. And so what we want to do now is use the answer in a sentence that describes its meaning, right? So remember that what we find here is a percentage difference, right? So it's a percentage difference between the absolute risk of regular tanning compared to not, right? So what the absolute risk reduction tells us, right? What do you think we could say at this point? What would be a good way to kind of wrap all of this up, utilizing that 0.15%? All right, so part B is asking now, what is the relative risk of melanoma from regular tanning versus no regular tanning? All right, and so now what we're looking for is something different, right? So we know a relative risk is the setup for a relative risk is a proportion, right? Where we have the absolute risk of one group divided by the absolute risk of the other group. Typically, the larger group goes in the numerator because we want a value greater than 1. So when it comes to calculating a relative risk, all right, we're going to want to set it up in a way where we take the larger percentage, convert that to a proportion, right? So we want to deal with proportions here. So in this case, I have to look at my larger values. And so my larger value is going to be the 0.35%. So I want to make sure that that's converted to a proportion first. So that's actually going to be 0.0035, right? That's the same quantity as 0.35%, but that's written as a proportion. And then divided by the other group, which is 0.2%, we're going to write that as 0.002 as our proportion. Okay, so now our setup here, this should give us something familiar. It should give us a familiar number because we kind of worked it out backwards last time, but this time we're kind of working it forwards in a way to find what the relative risk is. So between 0.0035 divided by 0.002, what we get is the 1.75. All right, so that's our relative risk. And so then again, we're kind of asked to use the answer in a sentence that describes its meaning. Okay, so what could we potentially say here about this value of 1.75? How can we write a sentence here that creates some context as to what the relative risk means? Let's see, it's 0.0035. I apologize if that looks like an 8. This is a 3.5. Basically, what I've done is when you deal with relative risk, you want to deal with proportions. Proportions are the decimal values, not the percentages. So what I've done is I took the percentage here and I converted it to a proportion by moving the decimal to the right 2 spaces. I'm sorry, to the left 2 spaces. Okay, so that's what creates my proportion. I did the same thing with this one, right? Since that was the smaller value, I took that percentage and then I made it the other proportion of 0.002. Yeah. And the reason why when you're dealing with the relative risk, the reason why it needs to be in proportion is because the value that you get out here, you need to think about this value as a multiplier. So it can't be a proportion, it can't be a percentage. We can turn it into a percentage later, but the 1.75, we need to think of that as like a factor by which you multiply. Right. So it's like, how do I get from 0.002 to 0.0035? I would have to multiply my risk by 1.75. And that's how then I would arrive at this other risk. Okay. So it wouldn't make too much sense if it said take 0.002 and multiply by 1.75%. Right. So you see how I try to eliminate the percent from it by converting both of these values into proportions first. Then my output reads more as a number, not so much as a percent. Okay, so now we kind of have both of these measures, right? We have an absolute risk, which tells us, and somebody shared here, we can say that the absolute risk or that the absolute risk reduction from regular tanning versus non-regular tanning is 0.15%, right? So essentially what we're trying to say is that there is an increase in percentage, right? The increase in percentage risk from regular tanning or from not regular tanning to regular tanning is like blank, right? It does matter which number is the numerator and denominator. Yes, for relative risk, yes. The bigger number, the larger value should be the numerator. The smaller value should be the denominator. Okay, so real quick here, let's kind of wrap up both of these, right? Since we have some statements that we can write regarding absolute risk reduction and relative risk. So let's say that there is a 0.15% increase in risk for developing melanoma in women who regularly tan or regularly use tanning beds compared to women who don't regularly use tanning beds. Okay, so here we're kind of explicitly, clearly stating what the absolute risk reduction is that it is just a 0.15% increase. Okay. Now versus what we could say regarding relative risk, right? How does the statement for relative risk, how is that slightly different from what we found in the risk reduction? How would that phrasing be different? What could we say about it? How could we describe what the 1.75 means in this context? Right? Remember that the 0.002 represents the absolute risk of women developing melanoma who don't regularly tan using tanning beds, and the 0.0035 represents the absolute risk for women who are the risk of women developing melanoma after regularly tanning. Right. So what does the 1.75 represent? What do you mean? People in the middle.
Like you have one group of people who don't tan, another group of people who do tan, and then like wouldn't they be like the middle? So they do,
Kind
but
of.
not like people who do
Not
tan.
really the middle, because it's like either you do tan or you don't. So there's not really like a middle ground. Um, so what the proportion represents is like how many times more likely, right? That's typically what that number tells you, right? So that's why I don't like leaving it as a percent, right? So that you're just thinking about this number as times more likely. And so times more likely what? So you have to then throw in where the two groups belong in terms of this number, right? So if I do tan using a tanning bed, I am blank times more likely to develop melanoma than a woman who does not regularly tan, right? And that's where that number fits in, right? So that number, the relative risk number, is telling you how many times more likely you are to develop something as a result of using a tanning bed or not. Does that make sense? Okay, so then let's write that, right? So um, women who regularly use tanning beds are 1.75 times more likely So women who regularly use tanning beds are 1.70 times more likely to develop melanoma than women who did not tan regularly. And of course, right, tanning beds is what we mean. So Angel, the 0.15 increase, right, that's more so with absolute risk reduction, right? Because that tells us the difference, right? So there is a percentage increase, right? So absolute risk reduction will always, you always talk about the percentage increase, versus relative risk tells you how many times more likely, right? And it's like by a multiplicative factor, right? So like if I tell you something like you're 3 times more likely, right? You kind of understand that because it's a product times 3, right? Like take my percentage and then you multiply that by 3, that's how much more likely I am. When you say multiply by 1.75, it's kind of hard to picture because it's not really like a whole number, right? But if I tell you you are twice as likely, right? It's like multiply my chances by 2, or 3 times more likely, multiply my chances by 3, right? So multiplying by 1.75 does increase your likelihood of developing it, right? Not quite to the point of like doubling my chances, but it's getting there, right? So imagine if it was just 0.25 more, now we have women who tan are twice as likely, right? Double as likely to develop melanoma from using tanning beds than people who don't, right? So there is a certain level of like power in that statement because it does tell you that your chances are increasing by a significant amount, right? Versus telling somebody that there's a 0.15% increase, while it is factual, it doesn't have the same kind of effect, right? It's like, oh, the percentage of me getting something didn't even go up by a full percent. Like it's not that big a deal. But if you warn people and you tell them like you are almost twice as likely, right? Not quite, but almost twice as likely of developing this skin cancer if you're using tanning beds regularly. That has a little bit more power to it, I think, right? And so that's where the relative risk kind of comes in the sense that it, right, it shows you what you would multiply your chances by. All right. Any questions so far about these two? Right. I want to make sure that these are clear, right? So that if you're asked for an absolute risk reduction statement, you're using it correctly by telling me the difference of the percent. If you're telling me a statement regarding relative risk, you want to make sure that you are utilizing the value as a product, right? So that's why we use 1.7 times more likely, right? Literally multiplying by 1.75. All right. Any questions so far? Okay. So let's kind of find out what we've kind of talked about C a little bit more informally here, right? So the units for absolute risk reduction are percentage points. Okay, that is a fact, right? So you see how with absolute risk reduction, the data that we present is a percent. Okay. And then it asks, what can you say about the units for relative risk? Right. Well, we also discussed that just now, right? That the units for relative risk should not be percentages. The units for relative risk should be just numbers, right? Like a number, whether it be a number and a decimal attached, but we are not trying to convert the relative risk value into a percent because then it becomes slightly misleading, right? We talked about that last time with like 113% increase, right? That's not quite the same as saying like 1.75 times more likely versus there's an increase of 175%. That's like, it's not quite factual. So the units for relative risk should not be percentages, okay? Not percentage points. So we're okay with a relative risk value that is just a number, okay? That's our multiplicative factor. All right, and so now let's head over to part D. Okay, so part D is very similar to a type of question that we answered early on in the year. All right, so in part A, the absolute risk reduction may seem very small, right? Which it is, it's 0.15%. Okay, however, it can be estimated that every year, nearly 2.3 million American teens use tanning beds. Okay, how many cases of melanoma do you estimate could be prevented if they did not use tanning beds? Okay, so this should kind of bring you back to that question that we answered regarding how many cases of lung cancer could we prevent if smokers didn't smoke, right? This kind of takes us back to that same question. How many cases of melanoma could we prevent if the 2.3 million teens didn't use tanning beds? Okay. Right now, we're not gonna put anything in the Google Doc. Don't worry, this is all just notes. All right, so let's take a look at how we could approach D. Okay, I know that we you might want to pull up what we did last time, right? You should have those notes available to you somehow. All right, I'm just going to kind of write over the information that we have. So we know that about 2.3 million teens utilize tanning beds. And we know that there is a 0.35% absolute risk for those who use tanning beds. Right, and ultimately develop the melanoma. And then we have 0.2% who don't use tanning beds use tanning. I should be more specific. Okay. So we're just considering these teens, all right? 0.35% do not use tanning beds. I'm sorry, 0.35% of them use tanning beds and develop melanoma. Meanwhile, only 0.2% of them who don't use tanning beds still develop melanoma, right? So what we're seeing here is something similar to that previous question with smoking, was that there were still some non-smokers who developed cancer, right? Not a lot of them, but there was still a percentage of them who did. So here's kind of where we want to start. How many of these girls, right, might still develop melanoma anyway, right? Like ones that we cannot affect regardless of what we do, right? Maybe there are kind of like those genetic factors, or maybe depends on where they live, right? That they're exposed to sun, or maybe they're lighter skinned. Who knows? Maybe there's some other factor that might account for the fact that there's still some percentage of girls who are, or teens in general, right? Maybe boys and girls, teens who develop melanoma regardless whether they use tanning beds or not, right? So can we find out how many of those teens would still develop melanoma? What could we do mathematically to find that? All right, so let me start you off at least, right? We have 2.3 million teens to consider. Okay, now remember, not all of them get melanoma, even if they use the tanning beds, right? So we want to find out, according to our data, right, how many girls or boys, how many teens could we expect to get the melanoma, even if they all use the beds, right? So in order to do that, this is where we're going to take our percentage, convert it to a proportion. All right, so we have 2.3 million, which means 2,300,000. That's a zero. Okay, and we want to find out of those 2.3 million teens, how many are going to develop melanoma if they all use tanning beds, right? So if they all use tanning beds, we would want to multiply that by a proportion, right? So we would have to take the 0.35%, convert that to the proportion 0.0035. This is going to tell us how many of the teens would develop melanoma if they did use tanning beds, okay? Okay, and what we're getting is that the value would be about 8,050. All right. Now, let's see how many of them would get melanoma anyway, right? How many of them would get melanoma anyway, even if they didn't use tanning beds? Okay, so let's now think, okay, these are all the kids that would get melanoma if they use the tanning beds. What if now we shift all 2.3 million teens, we take them and we convince them, do not use a tanning bed, right? We're going to be able to find how many of them would get melanoma anyway, all right? And then we could find the difference of how many kids we probably prevented melanoma from occurring in their skin, right? So now we find 2,300,000. And this time we multiply that by a factor of 0.002, right? So I'd still take my percentage, convert that to a proportion, and I believe here what we would get is 4,600. Yeah. Okay. So here are teens using tanning beds and getting melanoma, right? That's my value. Here are teens not using the tanning beds, right? We convinced all 2.3 million of them not to use them. But still getting melanoma. Okay. So if we did manage to convince all the kids not to use the tanning beds, how many cases could we prevent? What would we do with those two values? What would make more sense? Adding, dividing, subtracting, multiplying? I'm trying to find out how many cases I prevented. Right? I know that if I would have let all those kids use those tanning beds, about 8,050 of them would have developed melanoma. But by convincing them not to use the tanning beds, I've arrived at only 4,600 of them will develop melanoma. Okay, so the difference between the two values, right, is going to tell me how many cases we prevented, right? Very similarly to how we solved the previous problem with smoking and non-smoking. Okay, we want to find the difference between those two values because that tells us the cases that were preventable, right? Preventable cases. Essentially, these are the cases that are not preventable, right? I can't prevent this from happening because there are some other factors that are making this number true, right? Versus this one, some of these are preventable. Some are preventable because we are removing the variable of utilizing the tanning bed, right? So I just want to find out, well, then what is the difference, right? What is the difference between those two numbers? It'll tell me what amount of kids were, right, prevented from getting melanoma. So you do want to subtract. Okay, so we have 8,050 minus the 4,600. Okay, the value that we get is 3,450. Right, so 3,450 cases of melanoma could be prevented. Right, so these are the preventable cases if teens do not use tanning beds. Okay, if we would have divided the values, it would have given us something that wouldn't have made too much sense. Right, take a look at the number we would have gotten. 80/50 divided by 4,600. Right, it's 1.75. Right, and where does that come from? right? That's the risk factor, right? So basically, if you take 4,600 kids that are going to develop melanoma anyway, okay, you multiply it by the factor of 1.75, it tells you how many kids now are going to develop cancer or melanoma as a result of using the tanning beds, right? So that number shows up again, but that wouldn't make sense to say that 1.75 cases are preventable, because you can't have 0.75 of a person, right? And to say that you only prevented one case and then 3/4 of another person doesn't make any sense, does it? So although dividing is what we use to find the relative risk factor, right, and see how it shows up again, what we want to do is, once we know how many cases are going to occur as a result of tanning beds, how many cases are going to occur regardless of tanning beds, those two values, you want to subtract them. Okay, and then that tells you preventable human cases, right? You want to think of a case as like preventable person, right? Person who did not get melanoma, right? So although the percentage was small, right? Only an increase of 0.15% as in terms of a absolute risk reduction. Think about this value in terms of lives, right? And whether or not it's worth informing people about the risks of using tanning beds, right? Is it worth it? If you can prevent somebody from using it, maybe, right? Why suffer through something like melanoma if you don't have to? Just kind of like catch some sun outside, you know? I don't know. So do we see here kind of like the power of the descriptive terms? Okay, I hope we do. All right, so that kind of wraps us up for number 4. Are there any other questions for number 4? All right, cool. So number 4, a good problem that kind of takes us through each part: risk reduction, relative risk, and then how to find a group of people that are preventable, right? How many people we can prevent from developing melanoma. All right, let's move on to number 5. Okay, first of all, let's kind of look through what the key, most relevant information is, so that you have that down in your notes as well as you're going back and studying these problems. Okay. All right, so what we have here is now kind of the scenario regarding baseball pitchers, right? Or when they're young, right? So baseball pitchers age 9 through 14, right? So this is kind of our sample size. We're looking at kids who are playing little league, right? 9 through 14, right up until maybe like high school, right? So they were followed for 10 years, right? So this is one of these, what we call like a longitudinal study, where it's like you study something over a long period of time to see what the effects are, right? So, right, you could be pitching when you're young, but then you don't really develop any problems, shoulder, elbow, any issues, maybe until maybe like 10 years after. So they're followed for 10 years. 4 out of the 26 who had pitched at least 100 innings in 1 year had elbow surgery, okay, shoulder surgery, or they retired due to a throwing injury. Okay. Out of 128 who had not pitched 100 innings, only 6 had such problems. Okay. And so this study comes from the American Journal of Sports Medicine. So if you've ever kind of heard, maybe parents who say like, I don't want my son pitching, or I don't want my daughter pitching when they're too young, it's because typically while your arm is still growing and the tendons are developing, pitching too much can kind of disrupt the growth of those tendons specifically. And so you develop shoulder injuries, elbow injuries, things of that nature, as a result of putting so much strain on the arm, right, while you're throwing. Okay. And so this isn't the same as just like playing warm up catch. Like if you pitch 100 innings and in an inning you throw an average of maybe like 15 to 20 pitches, think of the amount of throws that you have had, right? And when you're pitching, typically, you're not throwing like a warm up pitch, right? Typically, it's much faster than you would any other kind of throw. And so, kind of put all that into perspective. All right, so that's our scenario, right? So our sample size is just 9 to 14-year-olds, okay? We know that's our age group. And it was happening, they were studied for about 10 years, okay? But that data shouldn't really have much to do with the percentages that we find later, right? It's good to understand where my sample comes from and whether or not I'm going to use these values for percentages. In this case, we're not. This information is just to give us data about our sample. Okay, but what we do know is that 4 out of 26, right? These are the kids who pitched at least 100 innings and they had some sort of surgery or injury. Okay. The other set of kids would be out of the 128, only 6 had these problems, right? These are the ones who had not pitched as much. Okay, so we have the two groups. Right. So for part A, first it's asking us to compute the percentage of each group who had such problems. Compute the difference of the percentages. And then what is the name of that difference? Okay. Write an explanation for parents or young pitchers that explains its meaning. Okay. So, right, now that you know this information and maybe you know somebody like in your family and you know that like you have like a nephew or a cousin who's like pitching and he's only like 10 years old, right? Be aware of how much they pitch. Okay. So let's compute percentages for each group, right? So we have two groups. First of all, what are the two groups? Right, what would I call group 1 in this scenario? I could, but injury or no injury is kind of a response, isn't it? What would be, typically we want to categorize our groups in terms of like what was the variable, right? The explanatory, the thing that kind of explains the response. Exactly, right? So injury and no injury is the response. So whether they pitched 100 innings or whether they did not pitch 100 innings, okay? So group 1, we're going to go ahead and call this one pitched 100 plus innings. And then did not pitch 100 plus innings. Right? That kind of makes sense, right? Because that is the action that they're doing. And then whether they eventually get an injury is like the response as a result of pitching or not. Okay, so then for group 1, what is the percentage here that we want to set up, or the proportion, right? What would be the proportion here that would help us find a percentage? Okay, so 26 out of 100. 100 represents the innings that they've pitched, not that there was 100 people. So kind of reread that. Right, for those that did pitch 100 innings, how many were in the sample size and how many of those were getting hurt in the long term? Okay, so 4 out of 26 Okay, that's my proportion for group 1. What about group 2? What would that proportion look like? Yeah, 6 out of 128, that's right. Okay, so we had more kids not pitching more than 100 innings. Okay, so there was only a few, I mean, 26 that were pitching 100 plus innings. All right, so now this is where the misleading kind of comes in, right? It's like, well, which group, right, was more at risk of developing a long-term injury? Because you see, okay, well, there was only 4 who got hurt versus in group 2 there were 6, right? But we have to take into account how many of them were there, right? And so that's where comparing percentages is super important and vital, because we can't just tell which one is the more dangerous category to fit into just based on frequencies, right? So let's find out what these proportions are. So for group 1, 4 out of 26, we're looking at 0.1538. Okay, so really what that's telling us is 0.1538. So it's about 15.38%. Okay. Versus 6 out of 128. This translates into 0.046. We can round that up to 9, right? So 0.0469. Okay, but as a percentage, when we move this decimal over 2 places, this only is about 4.69%. So a little less than 5%. Okay, so 15% likelihood, right, or risk of developing a injury in your arm if you're pitching over 100 innings, compared to only a 4, almost 5%, right, likelihood of developing an injury as a result of not pitching 100 innings. Okay, so some people are still developing injuries. This happens, right? It could be that some of those kids, maybe their form wasn't the best, but injuries just tend to happen. Okay, so we've completed that first part of part A, right, which is to compute the percentage of each group. Okay, and then the difference, right? Find the difference. And when we find the difference between percentages, what is the name of that? Right? It has a very specific term, the vocabulary for it. When we find the difference, what is it that we have found? Yeah, it kind of a discrepancy, yes, but what is the terminology? What is the vocabulary term? Right? We introduced it at the beginning of the section, and it kind of keeps coming up again.
Absolute risk.
Absolute risk, what? There's one more name at the one more. When you find the difference between the two percentages, what is that last word? Absolute risk. Reduction. There you go. Right. So we subtract the 2. So what we're looking for here is the absolute risk reduction. All right. And so this will give us some information. All right. So let's subtract 15.38% minus 4.69%. So what we have is 10.69. Okay. So we found the absolute risk reduction. And part of it now is explaining it, right? Using this value of 10.69% in some context to explain this to a parent for young pitchers, right? Let's say parents who are going to put their kid into little league maybe for like the first time, and they know like their kid has a strong arm, so they think like I'm gonna have my kid pitch. Now, what would you tell them using this data? So the increase in risk is 10.69% for kids ages 9 through 14 who pitch over 100 innings. To develop an arm injury, right? Compared to those who don't pitch 100 innings. Okay. So that's important to mention when you're talking about absolute risk reduction and you're explaining that to somebody, right? That the increase in risk is 10%. Okay. Right? Now we can bring back the context, right? So the increase in risk is 10.69% for kids ages 9 to 14 who pitch over 100 plus innings to develop an arm injury, okay, compared to those who don't pitch over 100 plus innings. All right. Okay, so we're going to leave it there. We're going to continue number 5 on Thursday. Hopefully we can get through the rest of 5, 6, and 7. So right now the document that's up, don't worry about it. If anything, I'm going to unpublish it so that you don't worry about it for now. I want to make sure that we complete our lessons together first.